All right, welcome back everybody for another deep dive. And today we are tackling something that you are all super curious about, virtual machines.
Oh yeah, virtual machines.
We've got a ton of interesting articles, research papers, all that good stuff.
It's a hot topic.
So, have you ever wished that you could like run multiple computers on just one physical machine?
It's like a superpower,
Yeah,
right?
well, it's the magic of VMs. And get this, they're behind a lot of the stuff that we use every day. We're talking cloud computing, app development, like all that really cool stuff is powered by virtual machines.
Behind the scenes, yeah.
Okay, so before we get ahead of ourselves, let's break it down. What is a VM actually?
Okay, so at its core, a virtual machine, it's basically like a computer built with software
Okay.
living inside your actual physical computer. It's like a computer within a computer.
Whoa.
And the really cool thing about it is it acts just like a separate machine. Like it has its own operating system, it has its own apps, it has everything.
So it's like, if you imagine like an apartment building, it's like having separate apartments,
Yes, that's a great analogy.
each with their own little setup.
Yeah, each one has its own setup, its own rules.
Yeah.
They all exist within the same building, but they don't step on each other's toes.
I like that.
That's what virtual machines do. They let you run multiple operating system, like, programs. You could even run entire server setups, all on just one physical machine.
So you could have like Windows running alongside Linux, maybe even something super old school, all without them like conflicting with each other.
Exactly. And
Yeah.
that kind of isolation, that's really one of the big things that makes virtual machines so powerful.
Okay, color me intrigued. But how does this all work? Like, what's the secret sauce behind this virtual world?
All right, so the key is something called a hypervisor.
Okay, a hypervisor.
It's basically like the software that makes VMs possible. So think of it as, going back to that apartment analogy, it's like the landlord
Okay,
of your virtual apartment building.
I like it.
It sits between all the physical hardware and all those virtual machines, manages resources, makes sure everything runs smoothly.
So it's kind of like playing traffic cop, making sure that each VM is getting what it needs.
Exactly.
Okay, so there are different kinds of hypervisors.
Yes, there are. There are two main types. You have type 1 and type 2 hypervisors.
Okay.
Type 1, that's like the building's foundation.
Uh,
It's installed directly on the hardware.
Uh.
So they're often used in like massive data centers. They're super robust. VMware, ESXi, Microsoft Hyper-V, those are some popular examples.
okay, so those are the heavy lifters. What about type 2?
Type 2, they're more like the building manager. They run on top of an existing operating system. So it's like another program on your computer, essentially.
Okay.
Things like VMware Workstation or VirtualBox. Great for everyday tasks, like if you want to test out software or run a different operating system for a specific project.
Okay, so depending on what you need, you pick the right kind of hypervisor.
Exactly. Choose the right tool for the job.
Makes sense. All right, but here's something that I'm curious about. We got one physical machine, right?
Yeah.
How do all these VMs, how do they share resources like processing power, memory, all of that stuff? Like, it feels like it would be like a balancing act.
It is. It's definitely a balancing act.
So they all share those resources from the physical machine.
They do. They share the resources, but the key is something called dynamic resource allocation.
Dynamic resource allocation.
Yes, and it's kind of like a smart traffic system,
Okay. Yeah.
that adjusts routes based on congestion. So the hypervisor, it constantly shifts resources to different VMs based on what they need at that moment.
So if one VM is like working really hard, it gets more resources, and then another VM is just kind of idling in the background, it's going to get less.
Exactly. You got it.
Okay.
And that keeps everything running smoothly. Make sure that no single VM is hogging all the resources.
All right.
But there's another trick that they use. There's something called overcommitment.
Overcommitment. That sounds risky.
It is a calculated risk, but it's one of the big reasons why, the cloud can be so efficient.
Okay.
So overcommitment is when the hypervisor, it actually allocates more virtual resources than physically exist on the machine.
Wait, so you're giving out more slices of pie than you actually baked?
It works because the hypervisor knows that not every VM is going to be using all of its resources all the time. Kind of like an airline, when they overbook flights.
Yeah.
They're assuming that some passengers aren't going to show up.
Right. So it's a gamble, but it's a gamble that pays off,
Usually,
especially in the cloud.
especially in the cloud, because, needs are constantly changing there.
Okay, that makes sense. All right, so we've covered VMs, we've covered hypervisors, how they share resources. But what about like the nuts and bolts? What do VM files actually look like? Like what's going on under the hood?
Yeah, so it's like peeking behind the curtain of the virtual world, right? You have configuration files. They store all the settings for the VM. You've got virtual disk files. They hold the operating system, all the data. Log files keep track of the VM's activity. There are even snapshot files.
Snapshots.
Yeah,
I think I've heard of those. Are those like saving your progress in a video game?
that's a really good analogy. They're like time machines for your VMs.
Wow.
So a snapshot captures the entire state of a VM at a particular moment. And if something goes wrong, you can just roll back to that snapshot, just like hitting rewind.
So say you're like testing out a new piece of software
Yeah,
and it crashes your whole system. You could just go back to before you even installed it.
exactly. Just revert back. No harm done.
That's amazing.
So snapshots, they're crucial for developers, for testing, and even for like disaster recovery
Right,
situations.
right. Because we've really only talked about what VMs are, but now I want to get into what they can do. Like,
Mhm.
where do they actually fit in the real world? What makes them so important?
Okay, now that's where things get really interesting.
Yeah.
Because VMs are so versatile, the applications are huge. So one major use case is server consolidation.
Okay.
So imagine a company, right, and they have rooms full of servers, physical servers,
Tons of space.
taking up space, energy bills are through the roof. With VMs, you can run all those servers on just one machine.
So you're shrinking an entire server room down into a single box.
Yeah.
Yeah.
What does that mean? Huge implications for energy efficiency, cost savings, you name it.
That's huge.
And it's not just about like consolidating existing servers, right? VMs are a game changer for developers for software testing because they offer these isolated, like self-contained spaces where they can experiment without impacting their main systems.
So it's like a safe playground where developers can go and they can try out new code. They can try out different operating systems. They don't have to worry about breaking anything important.
Exactly. They can go wild in their virtual sandbox. Something goes wrong, roll back to a snapshot, no problem.
Right. Speaking of safety nets, I imagine that VMs are also really important for like disaster recovery.
Oh, absolutely. Huge for disaster recovery. So by creating backups of their systems as VMs, businesses can recover quickly from hardware failures, natural disasters, you name it. It's like an insurance policy for your data.
Yeah, that peace of mind has got to be worth its weight in gold. All right. But there's one more thing I keep hearing about, and that's VMs and the cloud. Are they connected somehow?
Oh, they're fundamentally linked. Cloud computing, it's all about delivering computing services over the internet. And VMs, they power a lot of those services.
Wait, so when I'm using a cloud service like Amazon Web Services, I'm actually interacting with a VM.
In many cases, yes.
Wow.
Services like AWS EC2, Azure VMs, Google Compute Engine, they all rely heavily on VMs to deliver that scalable computing power.
So, I mean, people are using virtual machines every day, and they don't even realize it.
Every day. It's incredible.
That's amazing. It's like VMs are like the invisible engine driving the cloud revolution.
Absolutely. But the world of virtualization, it doesn't stop there. There's another technology that's often mentioned alongside VMs, and that is containers. So containers, they offer a slightly different approach to virtualization, and they're becoming incredibly popular.
Containers, okay. Now you've really got my attention.
Yeah.
So, how are containers different from VMs?
All right, so imagine this. Containers are like roommates sharing a kitchen,
Okay.
and VMs are like separate apartments.
Okay, I'm listening. I like where this is going.
All right, so containers, they share the operating system kernel of the host machine, which makes them a lot more lightweight, a lot more efficient than VMs. Perfect for packaging and deploying applications quickly and consistently. Technologies like Docker and Kubernetes, those are built around containers.
So containers are like the leaner, faster cousin of the VM.
You got it. Powerful tools, but different jobs.
Okay.
Understanding the strengths and weaknesses of each is really key to choosing the right tool. And just like VMs, containers, a whole other deep dive. It's
Yeah.
duly noted. All right, but before we get ahead of ourselves, let's round out our VM exploration here. And I think it's important to have a balanced view. So let's talk about some of the pros and cons, some of the things that we should keep in mind.
Okay, so let's start with the good stuff.
Yeah.
VMs, they're incredibly efficient with resources.
Yeah.
Help you squeeze the most out of your hardware.
Okay.
They're flexible, they're scalable. You can adjust as your needs change.
Makes sense.
And of course, they can save you a ton of money compared to running multiple physical machines.
Yeah. And that isolation that we were talking about, I imagine that plays a big role in security as well.
Absolutely.
Yeah.
So by separating operating systems and applications into their own little virtual environments, VMs create that barrier that prevents one compromised system from affecting others.
Huh. So VMs sound pretty awesome. But I know there's always another side to the story. So what are some of the limitations? What are some things we should be aware of? Yeah, so one thing to keep in mind is VMs do have a little bit of performance overhead compared to running applications directly on the physical hardware.
Okay.
It's like having a middleman, you know. They take a small cut for managing that virtual environment.
Right, right. And I imagine that VMs also require like a decent amount of resources themselves, right? You need a powerful enough machine to be able to handle running them.
That's right. You need enough processing power, memory, storage to keep those VMs humming.
Uh-huh.
And as you add more VMs or they become more complex, managing them, it can definitely become a challenge.
Okay. So the takeaway here is VMs, powerful tools, huge potential,
Mm.
but choosing the right tool for the job and understanding those limitations, that's crucial.
Couldn't have said it better myself. VMs, they're not a one-size-fits-all solution,
Right.
but when used strategically, they can really revolutionize how we use and manage technology.
Well, there you have it. A whirlwind tour through the world of virtual machines. We've unpacked what they are, how they work, the amazing applications, and even touched on some of those limitations.
Yeah, and we've seen how virtualization has become like fundamental to modern computing,
Yeah.
powering everything from our personal devices to the vast cloud infrastructure that shapes our digital lives.
But before we wrap up this deep dive, I have one final question for you.
I'm all ears. Shoot.
So we've been talking about VMs, like these incredible tools, they're changing the tech landscape.
Yeah.
But, it makes me wonder, what's next? Where does virtualization go from here?
Ooh, that is a fantastic question, and it's one that a lot of really brilliant minds are trying to answer right now. VMs, they're just the tip of the iceberg when it comes to virtualization. You know, that whole idea of creating virtual versions of things. It could
Okay.
be applied to way more than just computers.
Okay, give me some examples. What else can we virtualize?
Well, I mean, we're already seeing the rise of virtual reality, VR, and augmented reality, AR. And those create these digital experiences that blend with the real world.
Yeah.
Imagine architects designing buildings in VR, surgeons practicing complex procedures using AR, even attending like virtual concerts that feel just like the real deal.
And it's not sci-fi anymore. I've seen those VR headsets becoming pretty common these days.
Right, exactly. And as those technologies get even better, the line between like physical and virtual, it's going to get blurrier and blurrier. We might even see entire virtual worlds where people can work, play, socialize.
Like in Ready Player One.
Exactly. I mean, who knows what's possible?
What other areas do you think are like ripe for this kind of transformation?
Virtualized networks. Virtualized networks have huge potential. So traditionally, networks have been built with physical hardware like routers and switches.
Hmm.
But with network virtualization, you can create these software-defined networks.
Sure.
Way more flexible, way more adaptable.
Yeah.
Imagine being able to instantly create new network connections, optimize traffic flow. You can create virtual firewalls, all with a few clicks.
That would be like having a virtual network engineer, like on call 24/7.
Exactly. And these virtualized networks, I mean, they're already being used in cloud computing to provide that on-demand connectivity.
Right.
But it could go way beyond the cloud. Imagine smart cities, traffic lights, sensors, cars, all connected through a virtualized network. Optimize traffic flow, reduce congestion.
Now you're talking, let's bring this back to our listener for a minute.
Mm.
How does all this virtualization impact their everyday life? Like, what's the takeaway for them?
Well, some of these advancements, they might seem like they're a long way off. The truth is, virtualization is already a huge part of our lives.
Yeah.
Every time you use a cloud service, every time you stream a movie, you browse the web, you're interacting with virtualized technology.
Right.
And as these technologies keep evolving, they're going to become even more seamlessly woven into our experiences.
So it's not even just about VMs themselves, but seeing like virtualization as this big trend that's changing how we're interacting with technology and with the world around us.
Yeah, exactly. And that's why it's so important to stay curious, stay informed about these advancements.
Yeah.
Understanding virtualization, that's key to understanding the future of technology itself.
Okay, well said. So let's zoom back in from the future for a minute. Let's recap what we've learned about VMs specifically. What are some key takeaways for our listeners?
All right, so first thing to remember, VMs, they're software-based computers that run inside a physical machine. They create their own little worlds for different operating systems and applications.
Right, like having multiple computers in one.
Exactly, each with their own set of rules. We talked about the hypervisor. It's the key to making all of this work. It's like the conductor of an orchestra,
Yeah,
making sure everything's running smoothly.
right.
We learned about the different types of hypervisors, from the ones that are used in these massive data centers to the ones you can run on your own computer.
And we can't forget about resource sharing and overcommitment.
Oh, yeah, those clever tricks. Helping those VMs make the most of their resources.
Yeah.
We also explored the world of VM files, from configuration files and virtual disks to those handy snapshots that act like time
Like
machines.
save points, yeah.
And then we dove into all the different ways VMs are used, from server consolidation, development testing, disaster recovery, even as the foundation for cloud computing.
So many different use cases.
And we even touched on containers, the leaner, meaner cousins of the VM.
Yeah, they're really revolutionizing software development.
I mean, we've covered a lot of ground. But the biggest takeaway for me is that VMs, they're more than just a technical concept.
Right.
They're a powerful tool
Yeah,
that's changing how we use and manage technology, making things possible that we couldn't have even dreamed of before.
absolutely. So for our listener who was initially curious about VMs,
Mhm.
you know, how does all this new knowledge help them understand what they were originally looking into?
Hopefully, they now have a much deeper understanding of the technology behind the things that they use every day.
Before we wrap up, is there anything else that you think they should keep in mind? Anything they should be thinking about as they continue to learn about virtual machines?
I think the most important thing is just to stay curious. Virtualization is a rapidly evolving field, and there's always something new to learn.
Well said. And on that note,
Mhm.
let's bring this back to you. You, our amazing listener. You were the one who sparked this whole deep dive with your interest in VMs,
Mhm.
now that we've explored so much. What stands out to you as the most surprising or intriguing thing you've learned?
Was it the apartment building analogy, or the idea that cloud computing relies so heavily on VMs? Or maybe that mind-bending concept of overcommitment?
Or did something we talked about spark a connection to your own work or interests? Are you thinking about using VMs for a project? We'd love to hear your thoughts.
You can hit us up on social media, leave a comment, whatever works for you. Your insights make this whole deep dive worthwhile.
And here's a final, slightly thought-provoking idea to leave you with. We've talked about all the amazing things that VMs can do, efficiency, flexibility, security. But there's a flip side to consider.
What do you mean?
Well, if we can create virtual versions of computers, networks, even entire worlds, what happens when those virtual spaces become so realistic, so immersive, that they start to blur the lines with our physical reality?
Ooh, that's a great question. It makes you think about the nature of reality, even ethics. If our digital experiences become as rich and engaging as our physical ones, how do we navigate that? What new challenges and opportunities will emerge?
Those are some deep questions, and they probably don't have easy answers,
Yeah.
but it's fascinating to think about, the implications of virtualization go way beyond just tech specs and use cases.
Exactly. And that's what we hope you take away from this deep dive. Knowledge isn't just about facts and figures, it's about understanding the bigger picture, the why behind the what.
VMs are a powerful tool, no doubt, but the real power lies in how we choose to use them and how we wrestle with the ethical and philosophical questions that they raise.
So as you continue exploring virtual machines, keep those questions in mind. The future of technology is ultimately shaped by the choices that we make.
Now, on that note, my fellow deep divers, we'll leave you to ponder the possibilities. Until next time, keep those brains curious and those explorations going.